Hi, everybody. Wish we were together, but here we go. Next time we have class, we are going to have a graphing quiz. So right now, we're going to do some graphing practice, and then we're going to work on our next section. All right, but first of all, let's practice our graphs. So there's 6 of them on the practice quiz. The actual quiz will have 3 problems, so it will be like this, 3 problems. And as you can imagine, there'll be a sine, a cosine, and a tangent. So we're going to practice a couple of each. So first, here we go. We've got 3 sine 1/5 x and -3. I'm doing the 1 heart side, cosine 4x and 3 tan 2x. All right, so here we go. We're going to sketch these, and we're going to list the period and the amplitude of each. So this is a sine. So let's get the shape down. Here's my shape. There's the shape of the sine. Then we have a cosine. Just doing the shapes. Cosine, we know what that looks like. Starts at the top of the hill, valley, other top of the hill. But this one's upside down. So we're going to start at the bottom of the valley. So there we go. There's half the valley. There's our hill. And here's the rest of the valley. Now make sure that when you draw your cosine, you are finishing where you started. So since we started at the bottom of the valley, we're going to end at the bottom of the valley. And then we've got our tangent, which we know is 2 asymptotes and a squiggly line up through the origin. Okay, so right now we have half credit. We've got all of our shapes drawn. All right, so now we gotta label things. Here we go, we're gonna label. So for a sine, we have to label, of course, those. Same with the cosine. And then we have to label all of the important points, which for the sine, top of hill, where it crosses, bottom of valley, where it ends. We know that normally these labels are 1 and -1. Those are the normal sine labels. But because we've multiplied by 3, these are going to be 3 and -3, because remember, this number multiplies the height. Another word for height is amplitude. So our amplitude is 3. Now, these labels, under normal circumstances, are 90, 180, 270, and 360. Those are the normal labels. But because of this, we've changed them. And what does that number do? That number divides the width, or the period. So we're going to take each of these and we're going to divide by 1/5. Now you will have a baby calculator to do this, but you have to make sure you can. And my suggestion always is, because we have trouble doing this division, my suggestion always is to remember that 90 divided by 1/5 is the same as 90 times 5. And 90 times 5, you can do that real easily on your calculator if you need to. 90 times 5 is 450. And then we've talked about this, that once I know that's 450, I can get all the rest of these by just adding additional 450s. So 450 and 450, another 450, and one more 450. So my period is 1,800 degrees. Now, obviously, I haven't drawn this to scale. Honestly, I don't have a board big enough to draw it to scale because this gets stretched so much. Instead of stopping at 360, it's all the way to 1,800. Okay, now we're going to do the same exact thing with the cosine, and truly it is exactly the same. I need these labels. There's a 3 out in front of this one too, so this is going to be 3 and negative 3. I know that normally my labels, and notice where I'm labeling, I'm obviously labeling where I ended, where I crossed, and the top of the hill. And normally those would be the same, 90, 180, 270, 360. But this time, I'm dividing, that's a divider, I'm dividing by 4. I can type that just straight into my calculator, or divide it, however you want to get it. 90 divided by 4 is 22 and a half. And then I can do 180 divided by 4, or I can just keep adding 22 and a halves. Doesn't matter. You're going to get exactly the same numbers. So for this problem, our amplitude is 3, and our period is 90 degrees. Now we have our tangent. And the good news is, we know there's no amplitude to a tangent. So there's no labels here. I do need to label here and here though, my asymptotes. I know that normally they're negative 90 and 90. But we've divided by 2. So now my labels are at negative 45 and positive 45, which makes my period, be careful, start to finish, my period is 90 degrees. Start to finish. All right, there's the first one. Let's do the one right next to it. While I'm erasing, you can go ahead and get started if you wish. See what you can accomplish. Because again, next time I see you in person, we are going to have a little 3-problem quiz where you are going to be sketching. Remember, you got to have the right shape and you got to have the right labels. All right, so what do we got here? Okay, so let's start, and you can do this out in whatever order you want. I'm going to go ahead and get my shapes down first. That's up to you. But I can't really have the right graph if I don't have the right shape, so I'm going to start with the right shape. This is a cosine. It's a positive cosine, so it starts at the top of the hill. So I'm going to have a hill, half a hill. And I'm going to have my valley, and then I'm going to have the other half of the hill. So here's my cosine shape. Now I have a sine, but notice this sine is negative. So a normal sine has a hill and then a valley. This one is going to have a valley and then a hill because of that negative. Remember, a negative out in front turns your picture upside down. And now I have my tangent, which I know is 2 asymptotes and a squiggly line up through the origin. Normally, there's a negative. The negative is going to turn it upside down. So instead of squiggling up through the origin, we're going to squiggle down through the origin because because of the negative. Okay, so all of our curves can be turned upside down if you put a negative out in front of them. All right, so there's the shapes. Hopefully you're on board with that. Now we're going to put our labels in, and we're going to find our amplitude and our period. Okay, well, the number out in front, remember, multiplies the height. So the height of my cosine curve is supposed to be 1, but I multiplied it by a half, so the height is a half. So my amplitude is 1/2. Now I need I need a label. Where I cross, bottom, where I cross, end. Notice I am ending exactly where I started. Normally, I would be ending at 360. 90, 180, 270, 360. Those are the normal labels. I've divided by a half. Okay, this is another one. It doesn't matter to me. You'll have a little calculator. I don't care how you come up with this label, but you have to come up with 180 here, because you have 90 divided by a half. 90 divided by a half, which is 90 times 2/1. If that's 180, then this one will be 360, because it will be another 180. And then this will be 540, and this will be 720. I'm getting those because I recognize these are all equal equal intervals. And so if that's 180, then this is 180, this is 180, and this is 180. So I'm just adding 180. Or I can do this division for each of these numbers. So my period is 720 degrees. All right, now my negative sine curve, okay? So because that's a 2, I'm going to have a 2 and a negative 2, but my amplitude is just 2. Remember, amplitude, like radius and hypotenuse, always positive. Don't ever put a negative on a hypotenuse, on a radius, on an amplitude. They're always positive. Okay, I'm going to label here, 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 and here. So I'm labeling where I cross, where I end, low point, high point. They should be just like the problem we just did. They should be 90, 180, 270, 360. I'm dividing them by 2. So my labels are 45, 90, 135, and 180. So my period is 180 degrees. All right, and finally our tangent, our upside down tangent. Remember, no tangent anywhere has amplitude. Some of you are going to look at this 1/2 and you're going to say the amplitude's 1/2. But what you're forgetting is that amplitude is height and tangents don't have height. They go forever and ever. Okay, we don't have any labels on this axis. Okay, there are no labels on the vertical axis for a tangent because there's no amplitude. Ever. All right, period. Well, I know normally these are negative 90 and 90. I'm dividing by a 4th. So hopefully we're getting the kinks worked out of this. 90 divided by a 4th is 90 times 4/1. 90 times 4 is 360. So this is negative 360, and this is positive 360. What does that make my period? Beginning to end, negative 360 to positive 360. My period is 720 degrees. Stretch out, 720. Okay, perfect. Next time I see you, that's what we're going to be doing. All right, now we're going to look at lesson 4-7. One of the things I should have included on your green sheet, and I didn't, is another set of rules. They're pretty easy, but I'd like you to add them to your green sheet. If you have your green sheet, let's add this. I really don't want you adding other things to your green sheet in case I let you use it in the future. But this I would like you to add to your green sheet. When we see this notation, or this notation, there are some things we need to know if we're doing the problem by hand. Now, we have used that button on our calculator before. You might remember that's the button we press when we are looking for an angle. When we have a word problem, you know, you got the eagle looking at the rabbit, and we want to know the angle of elevation or something like that. We use this button. But when we're doing it by hand, we have to know the rules. Our calculator knows the rules. We have to know the rules if we're doing the problem without a calculator, which is what's happening here. Exact value. I'm on lesson 4.7. which is on the back of page 37, and it says find the exact value. No calculator, do it by hand, okay? Now, if this number is positive, and when I say the number, there's gonna be a number here, so I'll just say X, okay, that number. So if X is positive, you are going to draw a picture in quadrant 1 for everything. So when I look at the very first problem, I'll kind of just do this one along with us. This is what I want on your green sheet. We have inverse sine of 1/2, okay? Now that is a positive number. That's what I mean, is that number positive? That's a positive number. So you are going to draw your butterfly bow tie triangle in quadrant 1. No matter whether it's sine, cosine, or tangent, if this guy right here is positive, your butterfly bow tie is going into quadrant 1. That's easy to remember, okay? You don't even need to write that down. I mean, I want you to write it down, but you wouldn't need to. You can remember that. If that's a positive number, quadrant 1. It's when it's a negative number that it gets a little trickier. So remember, this means negative. So if this number right here is a negative number, if it is a sine, inverse sine, you're going to draw it in quadrant 4. If it's an inverse cosine, you're going to draw it in quadrant 2. See what I mean? It's a little freaky. If it is an inverse tangent, you're going to draw it in quadrant 4. These are rules that we have, and there are reasons that we have these rules, but for our purposes, these are the rules. This tells you where to draw your triangle. So for all of these problems on this page, A through J, you're going to be drawing a triangle, okay? This tells you where to draw the triangle. Okay, so how does this work? Now I have my rules right here. How does this work? Well, this says the sine is 1/2. problem literally says, find the angle whose sine is 1/2. So in other words, if I were translating this problem, this is how I would translate it. My job is to find the angle right here whose sine is 1/2. Okay, what do I know about sine? Sine is opposite over hypotenuse. So this is a 1 and this is a 2. Okay, now you should recognize that triangle. This is one of your special triangles. And remember, if you're doing it by hand, it will always be one of your special triangles. So this is a √3. And you got to figure out now, how big is that angle right there? Well, it's across from the 1, and the angle that's across from the 1 is a 30. So the answer to the question is 30 degrees. Okay, that's it. That's all there is to it. It's that easy. So let's look at number 2, or B, letter B. Find the angle whose cosine is √3 over 2. Okay, now wait a second, guys. That's a positive number. Positive numbers are drawn in quadrant 1. Here's what I'm looking for right there, that angle. Cosine is adjacent over hypotenuse. So √3 over 2. Again, it will always be special if you're doing it without a calculator. So this is a 1. Oh my. Isn't this a 30? Across from the 1. So the answer to this question is also 30 degrees. I'm not surprised they're the same. We're only using 2 kinds of triangles, 30, 60, or 45, 45. So obviously, we're going to be getting a lot of duplicate answers. Let's look at the next one. The angle whose tangent is √3. Now I'm going to think of that as a fraction. √3 over 1. Notice it's positive. So positive means I'm going to draw it in quadrant 1 again. Tangent is opposite over adjacent. So opposite is √3, adjacent is 1, that makes the hypotenuse 2. And now how big is that angle? The angle is the answer to the question. This notation means your answer will be an angle. You start with the fraction, the answer is the angle. Okay, so what is that angle? It's across from the √3, so that one is a 60. Easy. Oh, now we have a negative one. A negative one. Okay, no big deal. You got the rules. You want to find the angle. Sine is -1 over √2. So this is a sine, and it is a negative. So sine negative. These are positives. These are negatives. So that's going to be in quadrant 4. So now I draw my butterfly bow tie in quadrant 4. That's the rule for the sine when it's negative. Opposite over hypotenuse. -1 √2. That angle is 45 degrees. Well, wait a minute, guys, wait a minute. It's down 45. Since it's down 45, the answer isn't 45. The answer is -45 degrees. Remember, if I go down, that's a negative rotation. That's a negative angle. F, and then I'll go back and use E. Sorry, this is F. So I'm doing an inverse tangent. I'm in quadrant 4. Opposite over adjacent, that's tangent. Opposite over adjacent. So again, don't I have a 45-degree angle? Opposite over adjacent. But since it's down here, I don't write 45, I write negative 45 for problem F. This is problem F. Okay, now I will do problem E. Sorry about that. Problem E. It is a negative cosine. So here's my cosine list. Negative, I'm going to draw in quadrant 2. That's the rule. Adjacent over hypotenuse, negative 1 over 2. Special triangle, the other side is root 3. Now here's your angle right here. I care about that angle. What is the measure of that angle? Well, it's across from the root 3, so I guess it's 60. But this is where you have to have your thinking cap on. Because if you said the answer was 60, if you just said 60 is the answer, that would not be in quadrant 2. 60 is over here in quadrant 1. So the answer can't be 60. Remember, you start measuring here. So the angle is actually that one. The angle is the one that makes a 60 in quadrant 2. So we got to figure out how big that blue angle is. You go, Jim, think about this for a second. We know that this is 180, right? Go all the way to 180. We stopped here. So we had 60 to go before we got to 180. So this angle has to be 120 degrees. How did I get 120? 180 minus 60. 180 minus 60. So the answer to problem E is 120 degrees. You have to be in quadrant 2 when you answer the question because it's a cosine negative. All right, now I'm ready for G. First thing you need to always look at is that's a positive number. And if that's a positive number, you're going to draw your butterfly bow tie triangle in quadrant 1. Sine, opposite over hypotenuse, root 3 over 2. That makes this side a 1. And if that's the root 3, then the angle I need is a 60 because 60 is across from root 3. Since that's in quadrant 1, the answer is 60 degrees. That is the angle right there. That's the angle that we're looking for. 60 degrees. It's a cosine, and that is a negative number. It's a cosine, and negative number. That means it has to be in quadrant 2. So I'm going to draw my butterfly bow tie in quadrant 2. Now I'm going to remember, I'm going to find this angle. That's the one I'm going to find. But that will not be the answer. The answer will be this angle. But I got to find this one first. This is the one I'm going to find first. Okay, so what do I know? I know adjacent is negative root 3 and hypotenuse is 2. Adjacent over hypotenuse. That makes the other side a 1. Special right triangle. And across from the 1 is 30. So that's a 30-degree angle right there. Don't say 30 is the answer, because if you said 30 was the answer, the picture would look like this. That's a 30. You need the angle that makes a 30 in quadrant 2. So what would that blue angle be? Remember, this is 180. The angle you want didn't go all the way to 180, so it's less than 180. It didn't make it all the way. It stopped here. Well, how much too soon did it stop? 30 degrees too soon. So if all the way to here is 180, but I stopped 30 degrees too soon, isn't that angle 150 degrees? And that is the answer to the question. 150 degrees. That was H. All right, now I'm ready for I. For a second, you need to draw a triangle, but opposite over adjacent has to be 0 over 1. Can you draw a triangle like that? Does that even make sense to have that 0 in there? No, it doesn't make sense. So think about it. What do we do when a triangle doesn't make sense? When we can't do it with a triangle, we're going to do it with a circle. When did we draw circles before? We drew circles before when we couldn't draw triangles. And that happened when the angles were on the axis. That happened when one of these was our angle. Okay? This point right here is the point 1, 0. Remember, my radius is 1. This is the point 0, 1. This is the point negative 1, 0. And this is the point 0, negative 1. One of these points is the right answer. Remember that tangent is y over x. So I need to look around my circle and find the point. I'm going to start right here. I need to find the one point. There's only one answer to all these problems. I'm going to find the one point starting right here at 0. Work my way around. Find the one point where y is 0 and x is 1. So I need y to be 0 and x to be 1. So in other words, I need the point 1, 0. Isn't that right here? It sure is. And what angle is that? 0 degrees. So the answer to problem I is 0 degrees. If that had not been the right point, I would have moved on to this one, and then to this one. I would just keep moving around the circle until I got the point that matched what I needed. The problem problem tells you what you need. In this case, you need y to be 0 and x to be 1, because it's a tangent, and tangent is y over x. All right, let's look at the next one. I always write if I just have a plain number, I always put it over 1, so that I have a fraction, in this case, opposite over hypotenuse. So I'm going to draw my picture. That's a positive number, so I should draw it in quadrant 1. But I think we're going to have a problem. Opposite and hypotenuse. You remember from geometry that the hypotenuse must be the longest side of the triangle. It is not possible for the hypotenuse to match a side. That is not a possible situation. That cannot happen. A squared plus b squared has to equal c squared. These cannot match. This has to be bigger. Shoot. That means the triangle doesn't make sense. Okay, what if the triangle doesn't make sense? Then I use my circle, which I just erased. But here we go, we'll start over. Remember, if you're using the circle, the angle you're talking about is one of these, right? And the points, this is good practice for us. This is the point, 1, 0, 0, negative 1, negative 1, 0, and 0, positive 1, where am I doing? 0, positive 1, and 0, negative 1. Okay, so 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So I'm using a circle, so I'm not going to do this. I'm going to remember the sign is y over r. Now I know my radius is 1. That part I've taken care of. I need y to be 1. Okay? R is already 1. R is 1 for everything. That circle has a radius of 1. But I need y to be 1. So I'm going to look around. So right here, 0. Is y 1? Nope. This is not the right angle. Up here. Is y 1? It is. So what is the answer to the question? 90 degrees. For your future reference, if a 0 is involved, if you have a problem and there's a 0 in it, one of these problems and there's a 0 in it, you're going to draw a circle. If you have a sine or a cosine that's 1 or negative 1, you're going to draw a circle. Okay? So those are going to be the 2 times you're going to have a circle. If you got a 0, or if you have a sine or a cosine with a 1 or negative 1, you will always draw a circle. I'm going to leave my rules up here for a minute. We're going to move into number 2, part 2 here. And these problems, when you look at them, always freak people out. Because they look so incredibly difficult. But in reality, they are quite simple. So we're only going to do a couple of these, but let's get a couple of them done. All right. Literally, this problem says, I'm going to write out what it says. Find the sine of the angle whose tangent is 3/4. Find the sine of the angle whose tangent is 3/4. Okay, you know, because you are good math students, that we always begin inside the parentheses. So, for the time being, I'm going to cover this up. And I am going to draw the angle whose tangent is 3/4. I'm going to draw a picture of that. Now, when I see this notation, I'm either going to draw a picture in 1 or 4. That's a positive number, so I'm going to draw my picture in quadrant 1. Okay, so right now I'm ignoring this. I'm dealing with the parentheses. Okay? Now, I know that tangent is opposite over adjacent. So in my triangle, opposite is 3, adjacent is 4. That is not one of my special triangles. I'm not looking for the angle. I need to find the hypotenuse. We've done this many times. I drew a picture where opposite was 3 and adjacent was 4. Now I need the hypotenuse. So 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. So the hypotenuse is 5. So I drew my quadrant 1 angle, labeled opposite and adjacent, did the Pythagorean theorem, found the hypotenuse. Now I got my picture. Now what do I want to know about that picture? I want to know its sine. What is sine? Opposite over hypotenuse. So the answer to this question is 3/5. Okay, there's a couple of steps, but it's stuff you already know how to do. All right, let's do one more of those. And then we're going to type them in on our calculator, and then we'll be done for the day. So what is B? Find the cosine. Of the angle whose sine is 5/13. So think about the one we just did. How did I start? I started the way I start everything. I drew a picture. What did I draw a picture of? The part that's in the parentheses. We start inside the parentheses. So this is an inverse sine. It's a positive number. So again, I'm going to draw it in quadrant 1. Sine is opposite over hypotenuse. Okay, I'm not looking at that right now. This is what I'm doing, the parentheses. So opposite over hypotenuse. Now what? Look, what did I do last time? Pythagorean theorem. So a squared plus 5 squared equals 13 squared. So a squared plus 25 equals 169. You got a calculator. So a squared equals 144 and a equals 12. Worked out perfectly. They don't always. You can imagine you're going to have radicals in some of your answers, and that's okay. All right, I've done the parentheses. Now I need to remember what the problem was. I need the cosine. So now I have drawn my picture. I need the cosine. This is the picture. I need the cosine of the picture. So in this picture, the cosine is adjacent over hypotenuse. So the answer is 12/13. Oh, shoot. I didn't write down, was the answer to A, I think the answer to A was 3/5. I erased it. I think the answer was 3/5. All right, and this is the answer to B. So here's what we're gonna do. We're gonna type them in on our calculator now, because on test day, you're gonna need to be able to do both. Okay, so let's do this one first, since I have it written down. This is problem B. And you are gonna type in exactly what the problem says. So if you press cosine, the parentheses automatically come in. So then do second sine, that's how you get this. More parentheses come in. 5 divided by 13. You can go ahead and close the parentheses if you wish, but you actually don't have to, because there's nothing else to type in. The problem ends. So you can just press enter, and you get some decimal, 0.923. Okay, now here's what I want you to do. To prove that you're right, I want you to press your math button, right here, your math button. The first option up there is frac. Just press enter, and enter again, and guess what it says? 12/13. So the exact answer, the answer done by hand, is 12/13. The answer done on your calculator was 0.923. All right, let's do the other one on our calculator. The problem was this. And our answer we got was 3/5. Let's see if we get 3/5. So we'll press sine, second tangent, 3 divided by 4. 0.6. Isn't 3/5 0.6? Yes. So we did it on our calculator, and we did it by hand. All right, I'm going to stop right there, make a note. And we will, for next time I see you, we have our graphing quiz, and we will continue this. If you want to get a head start, next time we will finish 4.7 and begin 4.8. So next time I will assign 4.7, so if you want to start getting a head start on that homework, you can, but I'm not assigning it quite yet. All right, have a great day. Stay warm.